Okay, this next question, we have to do a little bit more work before we get to the actual graphing part. So the volume of blood flowing in a blood vessel, V, in milliliters, all right, so milliliters, is directly related to the square of the internal diameter of the blood vessel, D, in centimeters, all right? A volume of 100 milliliters flows through a 0.34 centimeter blood vessel. 0.34 centimeter blood vessel. Okay, so it has to be, D is in centimeters. I just have to take note of a few things here because we don't want to mess things around and get our units wrong. So this is where it's important to get a sense of the question. Milliliters, centimeters, we've got D, we've got V. Okay, now here's what we have. We have, if the equation, this is part A, if the equation to model this relationship is of the form V is equal to AD squared, okay, that's a general form where A is a constant, as in a number, use the known information to write the equation connecting volume of blood and internal diameter of blood vessel. Now, what is the known information? That's the question. The known information that's given to me in the question is a volume of 100 mils, 0.34 centimeters of blood vessel. So that information is going to give me A. So we find A with V equals 100 and D equals 0.34. Remember, it's in centimeters, so we need to do that. So 100 is equal to A times 0.34 squared. So if we want to find what A is, we need to do A is equal to 100 divided by 0.34 squared, because I've divided both sides. So my value for A is equal to, we've got, just got to sort out my calculator here, 0.34 divided by 0.34. A is 865.0519 . So I'm going to just do 865.05. And now that's a constant value. So what we end up with is the following. V is equal to 865.05 D squared. All right. So we've found what that is. Now, let's then go ahead and do question B. Draw the graph of this quadratic model for values of D up to 0.4. All right, well, I'm going to use technology to do that, just to speed up the process. So 865.0 D. So here we go. I'm going to go back to my decimals, turn off the previous one. Actually, I'll just delete it. Y, which is my V in this case, is equal to, what was it again? 865.05 D squared, which is x squared. All right, now what's going on here? Well, you see, once again, we've got a bit of a problem. We're talking about very, very small values. And if I read the question very carefully, it says, draw the graph of this quadratic model for values of D up to 0.4. Now, I've currently got my scale up to 15. So I'm going to set that. My x-axis, I'm going to go from about minus 0.2 to about 0.5. Okay, so there we have it. So we've got that. So that's kind of nice, isn't it, that we've got our values there. I can fiddle around a bit. So from 0.1, 0.2, 0.3, 0.4, and we see all those values going along there. So I'm going to just copy that, trim it slightly. So we have the values I need. We're only interested in this section of the positive one. We'll copy it, and then we will go along and put it in here. Then we can answer the other questions about it. Paste that in. I'm not going to do this just yet, so I'm going to add some space in here. Okay, now if we have a look at this graph, this is what I just graphed. V is equal to 865.05 D squared, right, with the diameter. The volume, so this is my V, volume in milliliters, all right, and this is diameter in centimeters. All right, diameter in centimeters. Okay. Now question C, use the graph to find the volume flowing through a blood vessel with internal diameter 0.26, 0.26 or 0.22, 24, 26, 28. So it'd be here, so we need to go up, so that's 0.26. Boom, 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 boom. Going over there. We go along there. So I'd say that's 60, 70, 80, 90, 100. So roughly 58. So part C is approximately 58 milliliters through a blood vessel of 0.26 centimeters. Part D. Use the graph. Now again, there's some element of error is acceptable here because of the graph and the way that you might draw it, etc. Use the graph to find the internal diameter of a blood vessel that has a volume of 80 milliliters of blood flowing through it. Okay, so again, we go to 80. I'll do this in green. 50, 60, 70, 80. So that's 80 up here. We go along here. This time we're going this way. We hit this line here. Slightly more than 0.3. I'm going to go with 0.312468. So 0.31 maybe. Approximately 0.31 centimeters. Vessel has 80 milliliters of blood flowing through it. All right, so that's that question. So again, we're working off the graph. So we go across from that one and then down. This other one, we went up from 0.26 and across to read 58. All right, so it depends on which way we want to read it off the graph. Confirm your answers for part C and D by substituting to the quadratic equation. All right, so this to do, we would have to do the following. This is part E. So if I want to know 0.26, so V is equal to 865.05 times 0.26 squared. Now what does that give me? 865, substituting in 865.05 times 0.26 times 0.26 squared. It's 58.47. Equals 58.5 milliliters. That's pretty close. And then the other one is saying, okay, if I have 80 milliliters, my volume is equal to 865.05 times d squared. Well, in this case, d squared is going to be 80 divided by 865.05 because we're dividing both sides, and that's going to be 80 divided by 865.05. 0.09248 dot dot dot, and then we take the square root on both sides. Take the square root, and we get d is equal to square root of 0.09248 is equal to 0.304. Equals 0.3 to one decimal place. So not too bad. Our answer was 0.31. That one, the answer was 0.3, so it should have gone almost directly through, or just slightly more. But point is, the graph was very close. Graph was very close. Okay, I'll do one more HSC question for you. Thanks.